Hi everyone. So today we are starting the demo of highly available active NFS server on GlusterFS storage system. So it's myself, Meghana Madhusudan, and I also have Soumya from the NFS-Ganesha team presenting the demo for you today. So let me roughly go through the agenda for the day. So first I introduce what exactly NFS-Ganesha means and what the entire scenario of integration of NFS-Ganesha and GlusterFS. And then I move on to the highly available NFS-Ganesha server that is implemented for GlusterFS 3.7. Then I give you a quick overview of the new Gluster CLI options that we have introduced to make the HA setup and teardown easy, and also export of NFS, export and unexporting NFS-Ganesha volumes. And then I move on to the active NFS-Ganesha, where a separate framework has been introduced. Samya will explain that to you, and a quick demo which shows the active HA implementation, where Ganesha on one of the nodes is killed, and we show you how it fails over from one VIP to another, keeping the IOs of the client uninterrupted. So what is NFS-Ganesha? So NFS-Ganesha is a user mode NFS server which supports NFS v3, 4.0, 4.1, PNFS, and also 9P. So we have something called as file system abstraction layers, which is used to plug into any storage mechanism. Right now, the upstream NFS-Ganesha supports file systems like GPFS, VFS, XFS, and now GlusterFS as well. And we have integrated NFS-Ganesha with GlusterFS using the libgf API library, which is available via GlusterFS API and GlusterFS API devel packages. And to export the volumes dynamically, that means to say having to export and unexport volumes without restarting the NFS-Ganesha. Ganesha uses something called as dbus, and by this mechanism we can unexport without having to restart the NFS server. So moving on to the high availability of NFS-Ganesha servers, which we have implemented and which will be available in the Gluster 3.7. So we have achieved this using Pacemaker and ChorusSync. And we also have implemented a HA script and several resource agents to put all this together in a single solution. So what do we need from you to make this work is, from a user point of view, we need virtual IPs that have to be given to each of the servers that you want Ganesha to run on each of the nodes. And these inputs are usually taken by a configuration file that's called ganesha-ha.conf file. And this script, it sets up and tears down the entire cluster. So Pacemaker and ChorusSync is used to create this HA cluster, and there is a heartbeat going on all of the nodes. And when any Ganesha server goes down, all the other servers are notified when this heartbeat goes down. And so what are we considering as a specific case for this presentation is, so we kill Ganesha on one of the nodes and see how failover happens. And what happens when a node goes down is we send a dbus signal to each and every node in the HA cluster saying there is a server that has gone down, and we put the entire cluster into grace, and then the VIP fails over. So to make all of this process easier, we have integrated with the new Gluster CLI to configure this and also the volume level exports. So what are the required packages? So Gluster server, Gluster API, and GlusterFS Ganesha RPMs are required for this. And Ganesha RPMs, we have our fixes in the latest sources, that is NFS-Ganesha. And also you'll need a specific package called NFS-Ganesha Sal Gluster, which is the file system abstraction layer that I talked about in the initial slide. So you would need this as well. And this is one of the most important slides because these contain the prerequisites for the user before he executes the CLI commands that need to be in place for the solution to work seamlessly. So basically, you have to populate etc hosts on all the machines. So let's say you have node 1, node 2, and node 3, and node 4. All these hosts have to be populated in each of the nodes. and then you have to disable and stop network manager service. And the third one is it's about the shared volume that we require for correct lock recovery when there is a failover. So we have to have a volume called cluster shared storage, and this name cannot be changed. It's mandatory that you use this volume name, and you mount it on a fixed path, that is var and cluster shared storage. And this has to be mounted on all the nodes on which you intend to start NFS-Ganesha server. And most important is use the GlusterFS native mount only to mount this volume on all the nodes. And uh, we are going to change this a little. We need more parameters, but for now you have to touch an empty file called ganesha.conf in etc ganesha, and you have to have the rpms that I talked about for pacemaker and chorusing for the resource agents to work well. So use pacemaker, cmac and chorusing and install all the packages on all the machines. Then you have to have a user called ha cluster on each of the nodes. um, this will take care the PCS commands to work correctly on all the nodes. So you need a same user, and make sure that you have the same password to all the nodes in the entire cluster. Then you have to run the command PCS cluster auth on each of the nodes, and PCSD does not start correctly without IPv6, so enable IPv6 on all the cluster nodes. Then do a service PCSD start. This service has to be started for you to create the cluster or tear down the cluster. And then populate. This is very important. You give your input using this configuration file. So you have to populate this file, and this file has to be same across all the nodes. So let's see how that file actually looks like. So you have to have a HA name. This HA name indicates the name of the cluster that you're going to create. So this cluster is need not be the same trusted pool of cluster servers. It can be a subset of it. So you have to have a unique name. So you cannot have the same name in this another cluster of the same name in the same subnet. Make sure that you have unique names. This is the first parameter. The second one is, as I talked about, there is a shared volume that you need to mount on each of the nodes. So from the server from which you are mounting that shared volume, and each of these servers have to have the VIP. So when you mount it using the VIP on the client side, for it to fail over to another VIP, so these VIPs are required for each of these servers. So have VIP underscore the name of your server and write your VIP against it, and each of them have to have it. So I talked about the script that we have introduced, resource agents and everything, but the user need not do anything directly. We have introduced new Gluster CLI to take care of these things. So the first one is a global option called Gluster features.ganesha enable or disable. So what it does in the background is it disables Gluster NFS. So you cannot have two NFS servers running on the same node. Neither do we want to end up in a situation where some of the nodes in the Gluster trusted pool run Gluster NFS and the other nodes run NFS-Ganesha. So before you enable Ganesha, you will be prompted if you want to go ahead and disable NFS-Ganesha in the entire cluster. If you say yes, only then will you be going ahead with this option. Then what it does is, if it is enabled, it starts the NFS-Ganesha service only on the nodes that you've specified in the previous config file on server 1, server 2, right? So only if it is there will it go ahead. Then it does a setup of the NFS-Ganesha cluster. So the Ganesha-hr.sh script is actually called by the CLI. You don't have to run it manually. And the second one is cluster wall set wall name Ganesha.enable on or off. So what the first option does is only those three, and it will just start the NFS service. None of the volumes will be exported by default. If you need any volume to be exported, you have to run this command. So what it does in the background is Ganesha needs a export file that it can recognize and to export that volume. So it creates the export config file with default parameters. Then it sends a debug signal and exports that volume without starting the NFS-Ganesha server. It also unexports it when you do a off. Apart from this, the Ganesha-h.sh script, apart from teardown and setup, it also is used to add node and delete node. So what does that mean? So in the Ganesha.conf, you see that there are a few servers that you've written and you've run teardown. So what if you need more nodes to be added to the Ganesha cluster? That's when add node and delete node come into the picture. We don't have direct CLIs for that. After a peer probe, you'd have to run the Ganesha ha.sh hyphen add node and delete node if you have to remove or add the node into the Ganesha HA cluster. So to achieve active-active NFS-Ganesha, there is a new framework that is introduced. Soumya will take over now and explain that to you. Thank you.
Yeah, thank you, Meghna. So myself, Soumya, I work for NFS-Ganesha team as well. So let me briefly explain about what exactly active-active NFS-Ganesha means and what are the challenges involved. So multi-head Ganesha servers, like as Meghna has been talking about, like we maintain a cluster of now NFS-Ganesha servers to run on a subset of nodes in the cluster storage pool. So that means that two multiple NFS servers would export the same volume to their clients. So what are the challenges involved in here is we should provide data consistency, and also we should avoid data corruption. So why is that a challenge? Consider like each NFS-Ganesha maintains certain cache. Like as you know, NFS-Ganesha communicates with cluster brick process using libgf API. So whenever it makes a call to the brick process, it caches the data, mostly the metadata, the attributes. So whenever next time any NFS client which is connected to that Ganesha head makes a request, most of the times it's most likely NFS-Ganesha will serve it from its cache. So in case, so if there is a change in the backend to the same file by the clients connected to another Ganesha head in the cluster, this Ganesha server wouldn't know, and it may be serving the stale data. So to avoid that, to provide that data consistency, we have introduced new upcall infrastructure. So let me get to what is exactly is upcall infrastructure. So till now in our cluster, clients initiate the RPC request to the cluster brick processes, and its client which when sent a RPC request, the server responds to the same RPC request. So there was never an infrastructure where server could send a callback request to the client on its own. So this upcall infrastructure has provides that. It's a general and extensible framework, and it's a concept where cluster brick processes maintain certain states for each of the files accessed, and whenever it has to notify client of about any change in that states, it can send a RPC callback request and notify that particular client. Here the client means cluster client, that is NFS-Ganesha server in this scenario. So one of the use cases of this upcall infrastructure, which is mainly used for HA active-active NFS-Ganesha, is cache invalidation. So what exactly cache invalidation means that, as I said, Ganesha servers cache the metadata whenever they make a RPC request to the brick process. So whenever there is a change in that file data or metadata, now the cluster brick process has to notify that particular Ganesha server which have recently accessed that file to invalidate their cache. So this is done by introducing a new accelerator called upcall in the brick processes, and that accelerator can be enabled by using the translator option features.cache invalidation on. It has another config option as well, cache invalidation timeout. So the reason we have this option is like whenever any application, including NFS-Ganesha, when it maintains a cache, there is a certain cache timeout value, right? So to invalidate its cache entry. So server needs to notify the clients which have the access the file within the timeout period. Post that it need not, because anyways the applications would have invalidated it. So we have made it configurable so that each application depending on its cache timeout, it can set it to the same value. So this is the second option which any application which want to use this particular cache invalidation feature can use. So that's brief about how active-active NFS-Ganesha is achieved. And let me just give a quick how it feels like in a HA. So consider we have 4 nodes here, node 1, node 2, node 3, node 4, and we have Ganesha servers running over there. So each of the Ganesha servers, as Meghna has explained already, we assign virtual IPs, distinct unique virtual IPs for each of these nodes. And all these nodes are configured in a cluster, and they communicate with each other using pacemaker corosync mechanism, pacemaker corosync. And also we have a shared volume storage, as Meghna has talked about. We need to have a shared state here. What exactly this volume contains is NFS servers, they maintain certain state of each of the clients which accessed files, mainly NFS v4 and NLM clients, because when those clients take a lock or delegation, when they have been granted a delegation, server needs to maintain a persistent state, like noting down which client has been granted what lock, because whenever the server reboots or goes down and comes back up again, NFS clients try to reclaim their old lock state. So that is why the server, to validate that, it maintains certain state, and the default location of that state is valid NFS on each of the nodes. And for the so in a cluster, when a failover happens, and suppose the virtual IP moves to a different node, that particular server needs to know the lock state of the first node which has gone down. So for that state has to be shared across the cluster. That's why we use the cluster volume. Being cluster being a distributed storage, we have used one of the cluster volumes to store the NFS state of each of these nodes in that volume, so that other nodes can access it whenever required. So we have to make sure that all the nodes are the shared volume is mounted on all the nodes, so that whenever there is a failover, then they can quickly access the NFS state of the node which has gone down. So consider they are connected, and suppose the client 1 is connected to a Ganesha server on node 1, and suppose the Ganesha server on that node has gone down. So now the first thing, as Meghna has already explained, first we put entire cluster into grace. The reason is, as per the NFS protocol, whenever any Ganesha starts, not Ganesha, whenever any NFS server starts, it has to be in grace, so that NFS clients which were already which were connected to that server before its reboot can claim their lock state or open state. For that, so here failover is also considered as a reboot of the server, so the NFS clients can reclaim their lock state. So for that reason, we put our entire cluster into grace, and then we move the VIP from the first node to the second node. So how the VIP movement is done is, for now we have used a round robin algorithm, like the way you have configured the HA servers in the conf file, which Meghna has already showed. So we just move to the next node in the list, and in case if the Ganesha server is down on that node as well also, then it will be moved to the next available node in the sequence of the servers which are mentioned in the conf file. So now after if IP fails over, the client will get redirected, and the Ganesha server on the second node will start serving the client. So yeah, that's about how HA works, and we'll quickly go to the demo, briefly explain how the failover works, and how to get a feel of it. Okay.
Looks like
looks like the Hangout hasn't showed any slides. Just a minute. Wait.
okay. No.
Yeah. So we are so sorry about it. Looks like the slides are not shown in the Hangout. So I'll just give a recap of what we had explained till now. So as Meghna had explained, the NFS-Ganesha has been integrated with GlusterFS using GF API library, and high availability is achieved by using pacemaker and corosync, and we have HS script which does the setup and teardown of the entire cluster, and new resource agent scripts which monitor the service and do the failover as we need. And the required packages are on the Gluster side, we need to install GlusterFS server API and the GlusterFS Ganesha RPMs, and on the Ganesha side you need NFS Ganesha and FSL Gluster RPMs. These are the set of prerequisites which Meghna had already explained. And this is a sample ha.conf file where you need to give the unique cluster name in the subnet, and the server which you have used to mount the shared storage volume, and the list of servers on which you want the Ganesha server to be running, and the VIPs for each of the server. So these are the CLIs which I have introduced to set up and tear down cluster. The first CLI, cluster featured as Ganesha enable, sets up the entire cluster. First it disables the cluster NFS on all the nodes, and then sets up the cluster of NFS Ganesha service. And the second CLI, wall-set Ganesha.enable on, will export that particular volume, export or unexport dynamically without disrupting the NFS service. And as I had explained, active-active NFS Ganesha is achieved using a call infrastructure. The GlusterFS maintains the state of the clients who all have accessed the files, and notify them whenever there is a change in the file on the backend. So this is the animation we have. Like consider a cluster of 4 nodes, and if a client and VIPs are assigned to each of those nodes, virtual IPs, unique virtual IPs, and they are communicate with each other in the cluster. Communication happens using pacemaker corosync, and the shared volume is mounted across all the nodes so that they can access the NFS state of other nodes whenever. So this is used whenever a failover is happens. This shared volume is used to read the NFS state of that node which has gone down. So whenever a client is connected, suppose the considered client 1 has connected to the Ganesha server on the storage node 1, and in case if the Ganesha server goes down, entire cluster is first put into grace, and then this IP will get failed over to a different node, and then clients will get redirected to the Ganesha server of that particular node. So let's give a quick demo of yeah. So yeah, we have a 4-node setup. Okay. We have a 4-node setup. Like let's quickly check if all the prerequisites are met. So as we know, PCSD should be running. Yeah, yes, PCSD is running, and just pre-check like NFS Ganesha hasn't started yet. Yes, and check if the shared volume is mounted. Yes, it's been mounted in var run cluster shared storage, and so check if Ganesha.conf is empty.
It is an etc Ganesha, Ganesha.conf.
Yeah. Right. Yes, empty. And PCS status. This PCS status can be used to check the cluster configured and the resource agents, their status, and if they are running, or if they have failed, or if they have failed over to a different, moved to a different node. So that all this can be seen using PCS status command. So let's just check what are volumes configured. So we have a test wall which we have created using the bricks from all the nodes, and also we have oops, sorry, I am in broadcast. Yeah. So yeah. So let me start the setup. So as we have mentioned, there is a CLI to set up the cluster features.ganesha enable. So when you enter first, it will prompt to for you to say yes if you want to disable cluster NFS. Yes. So cluster setup takes certain time. So I mean, it may take ranging from 2 to 3 minutes.
Yeah, 2 minutes. Yeah. In the meantime, you can explain
Yeah.
that script.
So in the meantime, let me log into the client machine. So we have written a small script which echoes hello world for about 50 times into the mount point, one of the files of the mount point. So during while it's the script is running, we'll kill the Ganesha service on one of the nodes, and after the failover, we'll see if the IO continues and if it has written all the data. So it's still running, looks like. So on the client side, let me just check if, yeah, on point has run.
You put this to off, right? The call
Yes.
option.
Yes. So for now, we haven't enabled the up call. So let me check. PCS status, as you can see, resources have been started. So let's just check. Sorry. Yeah. So let's check if NFS-Ganesha has started running on all the nodes. Yes, it's running. And show mount. Currently, no volumes are exported. That's why the export list is empty. And PCS status, cluster is set. We have here cluster IP1 refers to the virtual IP which we have configured. Everything has started on their respective nodes as configured. And if you want to see the virtual IPs, there's a command IP add. Sorry. Yeah. So you could see that the virtual IPs are assigned for each of the nodes. And yeah, I think, yeah. So let's start a volume, export a volume. So we'll use, sorry, broadcast off. So
this is the second CLI to export the specific volume.
Yeah. Okay. So it's success. As you can see, test vol is now exported. Let's just quickly check on all the nodes. Exported, and the export file would have got created in etc Ganesha exports directory. This is the file with the default parameters written. So as you can see now, currently upcall is enabled. I mean, the cache invalidation feature is enabled. I'll quickly show.
No, just info.
We info info, right? Sorry. As see, features.cache invalidation is off currently. So I'll see what I'll show you what is the impact of having this feature off in a multi-head Ganesha case. So let me just check what is the 170. I'll use 173 and 174 to mount the volume. So if I mount
173 and
40.173.
40.173.
And
so it's two different Ganesha heads serving the same volume.
Same volume, yes. So we have a file 1. So let me echo something to file 1 using the first mount, and I read it using the second mount. Yeah, hello. And even if first mount, hello. But let me just write something via the second mount. See, the first mount still shows hello, but if you see from the second mount, it shows the correct. So there is a kind of inconsistency in the data here. So let's unmount and quickly enable the cache invalidation feature and see how it changes now. So cluster B info. If you can see that cache invalidation is on. So let's just remount the volumes. Oops, yeah. So let's see, file one, it's one echo. So from the mount one, I did echo of hello. From the mount two to cat, it says hello. Let me just write something else from mount two, and as you can see, mount one has got updated quickly. So upcall infrastructure has sent a notification to the client, like Ganesha head on the node one, saying to invalidate the cache. So that's how the data consistency has been achieved here. So, and let's get to quickly check how the failover works. So as I have already shown you, we have written a script to test this failover. We'll run the script. It prints hello world for about 50 times into the file, and with a sleep command. So in between, if we kill the Ganesha service on that node, it should get failed over to the second node, and the client, the IO should happen with the second node, with the Ganesha server on the second node serving it. So
So the scoring actually happens in a way it is written in the config file. So if it is server 1, server 2, server 3, server 4, server 4 will have the second highest score. So the server 1 will ideally fail over to server 4 in our case.
Yes. Let me recreate file. Okay. Here I do. From another terminal, I'll read the data. Okay. So it's printing hello world. So now let me stop Ganesha service on that node. So you can check the resource status using PCS status. See, as you can see, cluster IP1, it's got moved to our node 4, RHS 4. You can check the IP here. See, the virtual IP is not present, but if you check the IP on this node, now it has the two virtual IPs, virtual IP of this node and the virtual IP of the first node. See, the IOs continues, that they are continuing without any disruption. Okay. Check.
It's written.
So yeah, it's written all 50 times. So let's quickly show how teardown works. So for teardown, it's the same thing, features.ganesha disable.
So this will also take a while.
Yeah, to tear down the cluster. Till then, I think I can show you the sources where the code is there.
So the CLI related changes are all made in features, Xlaters features, Ganesha.
And upcall changes are in Xlater features upcall.